Dear junior students, we are handling mathematics 1A. In maths 1A, we are handling the chapter trigonometry. Maths 1A in the chapter trigonometry. Yesterday I said exercise 6B, some problems and graphs of the sine and cos functions have learnt. Today we are going to discuss about the graphs of other trigonometric functions. So let us draw the graph of third question. Yesterday I said two questions. Draw the graph of y is equal to tan x. Draw the graph of y is equal to tan x in between the interval minus 2 pi comma 2 pi. Before going to draw the graph, let us write the values. X is equal to, this is x, this is y is equal to tan x minus 2 pi, like yesterday take the gap. Take the gap pi by 2, minus 2 pi minus 3 pi by 2 minus pi by 2. This is 0, pi by 2 and pi, 3 pi by 2 and 2 pi. We know that tan theta is equal to sin theta by cos theta. So, since sin n pi is equal to 0, yesterday I said that sin n pi is equal to 0. Since tan theta is equal to sin theta by cos theta, so 0 by anything becomes 0. That implies you can write tan n pi is equal to 0. So there is no question of 1 pi 2 pi like this. Then you can understand n belongs to z, not n belongs to rational number. 3 pi by 2, not pi by 2, not like that. So 1 pi, 2 pi, 3 pi, minus 3 pi, minus 2 pi like that. That numbers are 0. So whenever pi is there, put 0. This is 0. This is 0. Tan 0, 0. This is 0. This is 0. And now let us discuss tan of minus 3 pi by 2. Tan of minus theta is minus tan theta. Tan of minus 3 pi by 2 meaning minus tan 270 degrees. So minus tan of 180 plus 90 degrees. Tan 180 plus theta becomes tan theta only. So it is minus tan 90. Minus tan 90. Tan 90 value infinity are not defined. And means not defined. Here this is infinity, of course. This is all infinity. Tan 90 infinity, tan of minus 90 also. You can put here infinity. And tan 3 pi by 2, tan 270, of course minus infinity maybe. Tan of minus theta minus tan theta, this is minus infinity. So 0 comma infinity we are getting. So range of tan theta is 0 to infinity and minus infinity to infinity is there. So real number is the domain. Now there is no question of 1 and minus 1 like sine and cos. Draw like this: minus 2 pi minus 3 pi by 2, minus 2 pi minus 3 pi by 2, minus pi by 2 and 0. Here pi by 2. This is pi, 3 pi by 2 and 2. So for 0, for infinity means for tan 90 it is not defined. Whenever it is not going to define, simply draw a dotted lines. Minus pi by 2 and for minus 3 by 2. Draw lines like this. This is the way to draw the graph of tan x. Here everything is 0, so other than values. This is 0 like this. This is 0, this is 0. This is 0, this is 0. Here you can observe one thing, that the range of tan is minus infinity to infinity. So many values exist. Plenty of values you can exist the graph of in between the graph of tan x for one interval to other interval. So many values may exist for the tan x graph. But for sin x and cos x, even though so many values, plenty of values exist between the two consecutive intervals minus and 1. So the range should be minus 1 and 1. The sin x cannot reduce, cannot be decreased of minus 1, cannot be increased of 1. So minus 1 and 1 is the limit of sin x and cos x, but there is no limit for the tan x. So you can write now, since tan x is increasing sequence, put the line like this. Since tan x is increasing sequence, put the line like this. Since tan x is increasing sequence, put the line down to up. What, sir, why sir you are asking tan x is increasing sequence? So tan 0 value 0, tan 45 value 1, tan 90 value infinity. So it is going to upward. So curve should be in upward direction. Okay, from here like this. And again like this. This is the graph of tan x. This is the graph of tan x. Now let us draw the graph of cot x. Again, fourth question. Write the same question, same manner. Draw the graph of y is equal to cot x in between minus 2 pi comma 2 pi. This is the graph of tan x. Depends upon the same value, you can construct another graph of cot x. Rub the line. Here we can write, since cos odd multiple of cos 90 is equal to 0, remember the formula cot theta is equal to cos theta by sin theta. Cot theta is equal to cos theta by sin theta. Odd multiple of cos theta. Odd multiple of cos theta is equal to 0. So cot theta also, that is cot odd multiple of cot pi by 2 also 0. Odd multiple of cot theta also 0. So put here, this is odd multiple, 3 pi by 2 is odd multiple, there is no question of minus or plus, 0. This is 0, this is 0, this is 0. Now let us discuss about cot 2 pi. Cot 2 pi means cot 360 degrees. Cot 360 degrees, you can write cot of 270 plus 90. Cot of 270 plus 90. Cot 270 plus means fourth quadrant. In fourth quadrant, cot is negative. Minus tan 90 you can write. So this is a minus infinity. So minus infinity here you put. This is opposite, this becomes plus infinity. Now cot pi you can write. Cot 0 we know that cot 0 value cos 0 by sin 0 1 by 0 it is infinity. So cot 180 means cot, here I am writing cot 180, cot pi is equal to cot 180, that is equal to cot 90 plus 90. Cot 90 plus 90 minus tan 90, second quadrant. So again it is minus infinity. So cot pi is here minus infinity and it becomes here it is plus infinity. Now you can observe from negative it is, we are getting positive values. From 0 here, from 0 to here we are getting negative values. So for positive we are getting negative values, for negative we are getting positive values. Now you can conclude that cot x is a decreasing sequence. It is the reverse of tan x. So graph you can write like this. minus 2 pi minus 3 pi by 2 minus pi minus pi by 2 0 pi by 2 pi 3 pi by 2 and this is 2 pi. This is x dash, this is y dash. You can understand now the domain of the range of the cortex is infinity, minus infinity to plus infinity. Real numbers are there. We are going to discuss about the domain and range in next class. So simply I am discussing with you that range of sin x is minus 1 comma 1 and range of cos x is minus 1 comma 1 and range of tan x is minus infinity comma infinity and range of cot x is also minus infinity comma infinity. Now put infinity. Infinity means there is no definition. So minus 2 pi, put simply underline. This meaning there is no definition, not defined. Here also. 0 also. For pi by 2 it is 0. For pi also. For 2 pi also. Now, since cot x is decreasing sequence, minus cot 3 pi by 2 equal to 0, you should write like this. Put here 0, it is a mark, this is 0. And draw like this. From here to here, from downwards draw the graph. So reverse of tan x, like this you write. Reverse of tan x, like this you write. This is the graph of cot x. Now you can understand that the co-functions and original function graph are in similar way. So that is, graph of sin x and graph of cos x are the same. Graph of tan x and graph of cot x are the same. Same means the way I am discussing. Next, in the concept, graph of secant x and cosecant x also the same way. Now let us write the question. Graph of secant x. Y is equal to graph of y is equal to secant x. Secant x. Here you change students, it's unnecessarily. I did not rub the y is equal to tan x. Here y is equal to secant x. Remember that thing that secant theta is equal to 1 by cos. So depends upon cos values, you can write that cos 2 pi is 1. Of course it is nothing but cos 0. See the table of cos. Cos 2 pi is 1. So 1 by 1 becomes it is 1. Odd multiple of cos 90 equal to 0. So 1 by 0 becomes infinity. And cos secant of minus pi, secant of minus pi means 1 by cos pi. Cos pi we got the value minus 1. So here minus 1, 1 by minus 1. This is infinity. Secant 0 means 1 by cos 0. So it is 1. Secant pi by 2. So it is 1 by cos pi by 2. Cos 90 is 0. It is 1 by 0 becomes infinity. And secant pi is equal to 1 by cos pi. Cos pi already yesterday we discussed it. So it is minus 1, 1 by minus 1. Odd multiple of cos 90 equal to 0. So this is 1 by 0 becomes infinity. This is 1. So the value here 1 and minus 1. Minus infinity to infinity is there, but 1 and minus 1, between minus 1 and 1 we are getting draw like that. Minus 2 pi minus 3 pi by 2 minus pi by 2. This is 0. This is pi by 2 pi 3 pi by 2 and this is 2 pi. Put here 1. This is minus 1. Whenever infinity is there you simply draw the lines with meaning that not defined. Minus pi by 2. Here also simply draw the lines. It indicate not defined. Pi by 2 also not defined. 3 pi by 2 also not defined. Simply draw the lines. This meaning no value, not defined. Now put here the value minus pi. So what is minus? Secant of minus pi we got as a minus. Put here. And next one. Secant, this is for 0 it is 1. Put here the symbol. And for pi, for 0 already completed. For pi once again it is minus 1. For 2 pi it is 1. You can understand here according to our domain concept. Yes, according to our domain concept. If you are having 1A textbook, simply see the page number 238 and you get the domains and the ranges. Page 238, Maths 1A textbook. Page 238, Maths 1A textbook. Table 6.3 you see. It indicates that, of course, it is nothing but depends upon the graph. Minus infinity comma, the range is discussing minus infinity comma minus 1 union 1 comma infinity. Wherever you calculate the secant values, you cannot get the value between minus 1 and 1. That meaning is minus infinity comma range of secant x. You observe that range of secant x comma cosecant x is equal to minus infinity we got, comma minus 1 we got union 1 comma infinity. This meaning that there is no value between minus 1 and 1. So it is bounded to the value minus 1 and 1. Then you can understand this one using this one like this. Like a parabola, simply draw a number shape. This is a graph. Now, in the similar way, draw like this. In the similar way, draw like this. That meaning is there that there is no value between minus 1 and 1. Only 1 is there, or only minus 1 is there. You will not get the between the values. You will not get minus 1 and 1. Example: 0 is the value between minus 1 and 1. Secant how much equal to 0? You think 2 days or 3 days you take any time, you will not get any value. Secant, example secant 0, 1. Example secant 30, 2 by root 3, it is not 0. Example secant 45, root 2, it is not 0. Secant 60, it is 2, it is not 0. Secant 90, it is infinity, it is not 0. So you cannot get the such value between minus 1 and 1. To take any value from unknown value to known value, you can calculate, even though cannot get the from known value to unknown value also you can get. You cannot get the value. That is simply it is the bounded. It is called as the bounded or limited of the curve. Simply you draw like this. This means only it is 1. This means only it is minus 1. Only 1 minus 1. You are getting at the values minus pi. Between minus 1 and 1, you cannot get the values. Now draw the graph of y is equal to cosecant x. Draw the graph of y is equal to cosecant x. Here you change it, y is equal to cosecant x. Again the graph is of the values. You will get the graph of cosecant x also in the same manner of graph of secant x. Observe this thing, 1 by sin theta. Cosecant theta is equal to 1 by sin theta. So depends upon the sine table we can draw the values. Plenty of times I said that sin n pi equal to 0. There is no question of 1 by 2 pi. Here n belongs to z. So n is integer. So there is no question of minus or plus. Sin any pi equal to 0. So 1 by 0 becomes infinity. So yet pi concept is there, you put infinity. So here also infinity. Cosec 0 is infinity. This is infinity. This is infinity like this. Now minus 3 pi by 2. So cosecant of minus 3 pi by 2 means cosecant 270. Cosecant 3 pi by 2. Cosecant of, so minus cosecant 270 you can write as minus cosecant 180 plus 90. It becomes 180 plus theta becomes secant theta, so it is minus secant of minus plus secant 90. Secant 90 means of course 1 by cos 90. Cos 90 is 0. So again we are getting it is not right. Cosecant 3 pi by 2 becomes cosecant 180 plus 90, secant 90, cos 90 is 0, secant 90 is infinity. This is 270 cosecant. So cosecant 180 plus 90, number, whenever 180 is there, the letter will not change. So it is cosecant 90, this is 1. So put here it is 1. So opposite becomes it is minus 1. In the similar way, cosecant 90 is 1. So this is minus 5, but this is minus 1, this is 1. Now draw the graph in the similar way of the secant x. Right here minus 2 pi, minus 3 pi by 2, minus pi, minus pi by 2, 0, pi by 2, pi, 3 pi by 2, 2 pi, 1 minus. Whenever infinity is there, simply draw the lines. That means not defined. For 0 also, for pi, for 2 pi. Now put here for minus 3 pi by 2 1 indicate here like this. Next one for minus pi by 2 minus 1 put here. This is 1. For pi by 2 it is a 1, and for 3 pi by 2 it is minus 1. So this is the bounded value, draw like this. The bounded value, draw like this. In the similar way, this is the bounded value. This is nothing but parabola. You will be learning the concept of parabola in second year mathematics 2D concept. Now we have discussed completely. We have discussed the characteristics, domains, ranges of the and the graphs of the 6 trigonometric functions. Let us going to discuss about the exercise 6b. Exercise 6b, page 242 is there. Page 242, Roman number 2. Yesterday I said Roman number 1 sums are completed. Here, sketch the graph of the following. Sketch the graph. First one, tan x between 0 and pi by 4. Tan x between 0 comma pi by 4. So, known values. From trigonometric table, we consider 3, 0, pi by 6, pi by 4. It is enough. Only 3 values. X equal to x, here y is equal to 0, pi by 6, that is 30 degrees. Pi means 180. 180 by 4 means 45. Enough. Only for 3 values to take the graph. We know from trigonometric table, tan 0 is 0, tan 30 is 1 by root 3, tan 45 is 1. It is increasing sequence. Directly you can draw the graph like this. Take x-axis like this. This is 0, this is pi by 6 and this is pi by 4. Enough. Put here maximum value 1, this is 1 by root 3. Directly you can take tan 0, 0, tan by 6, 1 by root 3, tan 46, 1. Simply draw like this. That's all. This is the graph of y is equal to tan. This is first question complete. Let us discuss about second question. Cos 2x in the interval 0, pi. The graph of is asking cos 2x in the interval 0, pi. Now let us discuss here x, right here x 2x and y is equal to cos 2x. Here he is asking 0, pi. 4 values you can take 0, 45, 90, 0, pi by 4, between pi by 2, pi, enough. 0, pi by 4, take gap, so pi by 2, so it is 3 pi by 4 also take. 3 pi by 4 means 135 and this is pi. We should draw the graph of cos 2x, not with cos x. So multiply with 2 and get the values later. 2 into 0 becomes 0. So cos 2 into pi by 4 becomes pi by 2. Cos pi this is 3 pi by 2 and this is cos 2 pi. I said the value here. Y is equal to cos 2x. Cos here this is nothing but take like this. Cos 0 is 1. Cos 90 it means 2x equal to 90. Cos 90 equal to 0. Cos pi value minus 1. Cos 180 is equal to cos of 90 plus 90 becomes minus sin 90 is minus 1. Cos odd multiple 0, plenty of times I said. Cos 2 pi means it is nothing but 0. Cos 0 is equal to 1. Simply draw. Depends upon 1, 0, minus 1, 0, 1. Take x-axis and y-axis. Put here positive 1, put here minus 1, this is 0, this is y dash, this is x dash, this is x. 0 here, take here pi by 4, like this. Whatever the intervals he given, that only you should consider. Pi by 2, 3 pi by 4 and pi. For 0 we got 1, put here a symbol 1. For pi by 4 we got 0, put here 0 here. For pi by 2 we got minus 1, put here. For 3 pi by 4 we got 0. For pi we got 1, like this. It is increasing and decreasing. With this free hand you draw like this. That's all. This is the graph of cos 2x in the given interval 0, pi. Now sin 2x in the interval 0, pi. Here you need to calculate, you need to understand. Already I said the intervals concept. Closed interval. This is closed interval. Closed interval meaning it is there. 0 is there, pi is there, whatever the between values are, they also exist. Now third question, sin 2x is given, it is open interval, not closed interval. Sin 2x in interval 0, pi, open interval. This is called open interval. So open interval meaning there is no 0, there is no pi. You should not consider 0 and pi. So draw the table x, 2x and y is equal to sin 2x you take. So get the values from the known values. 0 you should not consider. So pi by 4, 45 known values. Pi by 4, next to pi by 2, next to pi you should not consider. Only 2 values. So better to consider trigonometric table values. Trigonometric table values, pi by 6 you consider and pi by 4 like this. Pi by 6, pi by 4 and pi means 180 you can understand. Pi by 6, pi by 4, pi by 2 and 3 pi by 4. Enough. For 2x you can multiply here pi by 3. This is pi by 2. This is 2 pi by 2 meaning pi. This is 3 pi by 2. Sine here you can understand sine pi by 3. Sine 60 value is root 3 by 2. Root 3 by 2. Sine 90 value 1. Root 3 by 2 you can understand root 3 is equal to 1.732 and 1.732 by 2 becomes 0.866. It is lesser than 1. Now sine pi is 0, sine 3 pi by 2 meaning sine 270, sine of 180 plus 90 minus sine 90 is minus 1. Now draw like this. From minus 1 to root 1. Put here 0, it is 1, and in the top you take 1. Put here root 3 by 2. Down you put minus 1. From here you start 5 by 6, 5 by 4, 5 by 2, 3 pi by 4. Indicate that at 5 by 6 root 3 by 2 is there. And at 5 by 4 1 is there. And at 5 by 2 it is 0. And 3 pi by 4 it is minus 1. So draw like this with free hand. Don't join 0 students. Simply like that. Now let us discuss about graph of sin x in the interval minus pi comma pi. So fourth question. Fourth question. Draw the graph of sin x in minus pi comma plus pi. This is closed interval. Closed interval. Closed interval meaning the values are there, minus pi is there, and between values also exist. Take minus pi by 2 gap. Here x and this is y equal to sin x minus pi by 2, 0, pi by 2, pi. Take the gap. Only 90 I have taken gap. Pi means 180, pi by 2 means 90, then you can understand the 90 gap minus pi by 2, 0, pi by 2 and pi. Plenty of times I said that sin n pi equal to 0. So sin, this is 0, sin 0 is 0, sin of minus theta is minus sin theta, so sin of minus 90 is minus 1. Put here minus 1, this is 1. Draw the graph. The value is lying between 0 and pi. So 0 and minus 1 and 1. This is 1, this is 0, this is minus 1. From here we started minus pi. This is minus pi by 2, this is pi by 2 and this is pi. For minus pi we got 0, put here symbol. For minus pi by 2 this is minus 1, for 0 this is 0, this is 1 and again we got 0. This is completely oscillating curve. This is the graph, this is completely oscillating curve. So up and down curve. Now write the fifth question. Cos square x in closed interval 0, pi. Cos square x in closed interval 0, pi. This is closed interval. Closed interval meaning 0 is there and pi is there, between values also exist here. Take x here. Take x. So cos square x we need to get. First cos x you write. Next cos square x you write. So 0 you can take. Take 45 difference. 0 pi by 4. Of course, for table values also you can take 0, 30, 45, 60, 90, 135 like this. That is your wish. But the graph will be in good position if you are taking the same difference. 0 pi by 4. So and this it is pi by 2 and 3 pi by 4 and pi. So 45, 45, 45, 45 difference I am taking. He is asking about cos square x. So whenever square is there, so every value is positive. Whatever the result we are getting. Now you write the value cos 0 is 1. Here cos 45 is 1 by root 2. Cos 90 is 0. Cos 135 meaning cos 90 plus 45 minus cos 45 it is minus 1 by root 2. Now cos 180 plenty of times we discussed it minus 1. You have to do the square of these values. This is 1 and this is 1 by 2, 0, this is 1 by 2, this is 1 by 2 and 1 minus 1 square is also 1. Draw lines. Everything is positive. Put here 0, take the difference 5 by 4, 5 by 2, 3 pi by 4 and pi. The value we are getting 0, 1 by 2, simply 0, 1 by 2, 1. Put here in the middle is 1 by 2, this is y dash, this is x dash and this is x. 0, 1 by 2, this is 1. Observe this one for cos square x we are getting 1. Put here, mark. Pi by 4, cos pi by 4 we got as 1 by 2 and cos pi by 2 we got this is 0 and for cos 3 by 4 again we got 1 by 2 and cos pi for cos square pi we got 1. So observe the graph. It is also oscillating graph. If you put here, you can get the proper way. Draw lines. This is the graph of the cos square x in between 0, pi. Until now, we have discussed the graphs, periodic functions and the periods also. Exercise 6b completed in mathematics 1a. Let us discuss about the theory, concept, sums. Of course, I said all sums formulae depends upon until transformations. That is depends upon the exercise 6f concepts. Completely, I said every formula. Let us going to discuss about the exercise 6c concept and sums examples in next class. Okay students, let us discuss in tomorrow class.